when they want to. Good afternoon. Thanks very much for coming to the session. My name is Ashok Sankar. I am with a company called Splunk. We're based out of San Francisco. We have a public sector office in McLean, Virginia, and we are distributed around the United States. What I want to do today is, it's just after lunch, so I don't want to be in a monitor. You really don't want me to hear talk for about an hour. I want to keep it interactive. So, ask any questions if I'm going too fast. What I want to be able to do today is essentially talk to you about machine data. What is it? How is that going to help you be more efficient, be more secure, be more productive, and believe it or not, delight your citizens, all at a low total cost of ownership. I want to be able to talk to you about that. And hopefully you'll get some, and I can give me some feedback on what I have to say, and see how you might be able to apply. Okay? So before I get started, I'll tell you a story. I was coming to Wilmington. I live in Northern Virginia, so I was trying to figure out, should I drive or should I fly? What should I do? And I have this app from my county, right? And I put in my particulars and said, well, I'm going to Wilmington, North Carolina on the 18th. Tell me what I should do, right? That's all I did. And here's what I'm going to do. And it went through a bunch of parameters, bunch of information that it had, the county, came back and said, it's better if you fly. And it gave me a bunch of reasons for it and said, this is the best way for you to get there, right? And I calculated the whole thing myself and it said, okay, I'm going to believe this app, right? Which was great. So I booked my flight, also told me what was the best flight route, what's the best value for the money, etc., etc. And then I was able to come here, right? In the morning when I was coming in, the evening before, I had also said, this is what I want to be able to do. My flight details were all there, right? And basically what happened was the county app was able to essentially set my alarm based on the flight conditions and things of that nature, right? So it was coming out on time here, so I had to wake up at 6:30. I lived very close to the airport, so it was not a big problem, right? So the other thing that happened was that when I was pulling out of my driveway, I noticed that my street light was gone, right? And so there was a little pothole, I didn't see it before, and I clipped it, right? I kind of hit it and went back, and I was thinking to myself, hopefully I didn't damage the car too much. So I drove to the airport. I was a little upset because there was a pothole there, the light was gone, things of that nature. The county should have fixed it as far as I'm concerned. I don't know why, they didn't see it. So I went off, and I came to the airport, and from the airport, of course, I flew to Charlotte, which is Mecklenburg County, and they had shared that information, right? So when I landed, it kind of told me, based on my health conditions, statistics, and things like that I shared with my smartwatch, right? From that information from there, it was able to tell me what the best restaurant to go was, what kind of wait times I had, from the route from one gate to the other, the gate where I was going on a flight from Charlotte to Wilmington, right? And then when I landed, there was a taxi waiting for me. And I just hopped in, I didn't have to pay him or anything like that, everything was taken care of. And I just came here, and I was able to alert my colleagues and say, I'll be there in about 15 minutes, that's what my app told me, right? So obviously the guy from Mecklenburg County is saying, that did not happen, right? So when we talk about this kind of a scenario, if you will, the point here is that, of course, I don't have a county app, the county app did not do it, right? And they did not fix my pothole before I got here or any of that nature. But with this concept of machine data, by harnessing this machine data, which we are finding more and more valuable, right, we're able to essentially create that scenario. That art of the possible is within our grasp, right? Customizing services and solutions specifically for individual citizens, right? Making us more secure. Making sure that the IT operations are functioning properly. Being able to get information from various sensors that you have, be it water meters, be it turnstile data, be it bus conditions, be it from a light on a street, wherever it might be, you're now able to essentially realize a situation where a citizen doesn't have to wait in line or wait for a web form to refresh at that level, or you have to worry about hunting all these threats and being overwhelmed with all these different things. So that's what I want to talk to you about today. Okay? And we call that machine data. But before we get into the details, one of the things I want to do is This is something I've got to show from the company because anything that I said right now was something that I just created, right, in my head. And I don't want you to think it's actually happening, but it can, hopefully in a few years, because we are essentially at that stage. When we talk to a lot of state and local folks, here are some priorities that they told us. Of course, cybersecurity is a very, very big thing, right? And at the same time, we're building smart cities, smart counties, right? Smart states and things of that nature. You have to delight the citizen if, for example, the lighting example I told you, I know they'll come and fix it, but I'm going to complain about it, right? I'm going to call and say, why hasn't it been fixed? It's been 6 hours, it's been 12 hours, 18 hours, whatever it might be. I'm going to start complaining about that, right? And this concept of open data, it's starting to rejuvenate itself. There is a lot of states, a lot of localities that are using that information, but it's come back again. The people are seeing the benefits of using open data. And of course, you want to be able to control fraud and waste. Is there anything here do you think I'm missing anything here in this list from your perspective? Do you see anything else that is more top of mind for you? Or is there anything here that you say, yeah, this is there, but we're not necessarily worried about it? Just want to get an idea. Yeah.
Well, and you may have it underneath one of those headings, but predictive. Predictive analytics.
Okay. And what would you use that for?
Well, potentially in public safety.
Okay.
If we see certain things going on, and we can figure out what the catalysts are. If we start to see that, then maybe we can be proactive. Predictive analytics in terms of equipment failures. Obviously, you don't know when the pothole's going to fail,
right.
The street's going to fail, but you may know something with that light.
Yes. Okay, that's great. Anything else? So, what are some of the reasons why, are you guys realizing all of this? If you agree with this stuff, I take it your security posture is just A1, world class, no problems, right? And you're controlling all the fraud and the abuse or any kind of waste.
Yeah.
You're running very, very efficiently. Can I assume that? Probably getting there, no? Some of the challenges that you might be facing? I just want to hear from you before I go to my next slide.
Let's just say we're all doing as good as well with cybersecurity protection as we can, given our budgets and the yes, budget, staffing, and the latest threat.
Okay. Okay, what does that really mean when you say that? When you say we are doing the best we can, what does that mean? Just curious.
Well, in some cases, maybe you can't afford maybe you'd like the Cadillac of tools, but maybe you have to settle for the Ford and Chevy version of the tools. And that, if you were looking more frequently or getting more data,
yeah,
you might could do a better job. But, when you're competing with everybody else for fire trucks and public safety officers in terms of funding or new garbage trucks, you get what you get.
Yeah, so is your cybersecurity funding, for example, a lot more the past couple of years than it was before versus other, or no? In general, it's been the same? Okay.
I think the awareness and the desire is there, but it really hasn't trickled through to the financial funding.
Okay. Okay, so but you're still, got a resource shortage and you still have to do more with less, right? Okay. So one of the things that I want to get to here is that we are operating in silos. Other than all of these different things that you have, right? You're claiming state aid, you have to do more with less and things like that. If you start to look at the problem, there are silos of operations that are going on, right? Even if you look at your cybersecurity initiative, the web infrastructure is being managed or done differently than maybe the security side of things versus the application side of things. Everything is in silos. What if, for example, you're able to get all these things in one place, right? Get some authoritative information about all these different things in one place and be able to, correlate and analyze it, right? Instead of the system telling you what is going on, right, and say this is what it's going to be. What if you're able to ask different questions, right? And be able to get some insights and get some answers, right? And that's where we're going with this concept of machine data, okay? So when we talk about machine data, first let's try to define it. What exactly is it, right? And if you look at any of your systems, there is machine data that is being generated. The easiest thing for you to maybe visualize is these log files that's coming out of your firewalls, your IDS devices, your network devices, web servers, whatever they might be. There's also usage and access data, right? Anybody here work with mobile device management tools? Okay. When you talk about mobile device management, I mean, there's a misnomer about them, mispositioning, I should say, about those being security devices, but they really are not. They essentially give you the status of what is going on the mobile device, right? Usage patterns, the battery life, any information you want about the sensors that are on the mobile device and things of that nature. That's an example, if you will. When your smartwatch, for example, is sending out information, that's machine data that it's sending out, right? You're not asking anything for it. You can ask for it, of course, but then, it's going to be sending out that information. The same thing with RFID, energy meters, weather sensors. So essentially, we are surrounded by all kinds of smart devices or sensors that is essentially creating this data deluge, this thing called machine data. And if we could harness it in some way, shape, or form, right, then we might be able to realize some value out of it. That essentially is the thesis behind this, okay? The key thing about machine data to understand compared to a lot of other pieces might be the fact that it's being generated every time there's an activity, right? Whether it involves a human or a machine, it does not matter. It's going to be generating an activity, right? It's going to be generating some data, but at the same time, it's going to be timestamped. So you've got a time series of data. So start to think about how this data is going to help you realize things, because it is just not there, right, at an instant, but you also have, a lot of information, over time that's, that you're going to get. Now, the second aspect of it, we talked about this, where it's getting generated, from multiple places. We talked about the area where, it's human to machine and also machine to machine. So it's got all the data that is coming along. When you take all this data and you collect, correlate, and you can analyze it, you can essentially solve problems in multiple areas, be it security, be it IT operations, is it even application delivery, right? And the area of business analytics and industrial data and the so-called Internet of Things. For example, when you have energy meters that you're sensing, you can try to look for information that's coming along. If there's information that is not coming, that might tell you something, right? That is something that you may want to go take a look at, see why it is not generating some information, right? That could essentially help you plug some revenue leakage perspective. From a revenue leakage perspective. Also, think about a case, this happened with New York State, where people have a home in New York State, right? And at the same time, they have a home in Florida. Because the tax rates, they essentially consider that New York home as a vacation home, which means they don't have to pay that much tax. But what if, from the electricity usage and the water usage, you're able to detect over a 6 or a 9 month period, that essentially says, this person who's living in this apartment, is not using it for a vacation home. It looks like it's his primary home because of the usage patterns around various other data that you're able to collect, right? That kind of essentially helps you, look at what this person is trying to do, right? Is it a primary home? Is it a secondary home? And then be able to get some, data around that. So what does machine data look like? Unfortunately for us, machine data comes at us very, very fast. The volume is just enormous, right? Because it's getting generated from everywhere. The third aspect of it, the most important, is that it's various types. The formats are very, very weird. So here I have some machine data that's coming from various sources. I have a transaction that was done. Let's assume it is a transaction. Somebody's trying to pay a water bill, or maybe just with the motor vehicles department or something like that, right? And that, for some reason, fails. Right? And they call the support center, and then they tweet about that experience. All that machine data is captured in this case. And if I parse through this machine data, I can get some intelligent information out of it. I can see a customer ID, I can see the order time, the time wait on hold, and what kind of tweet was sent out, what was their handle, etc., etc. If I'm able to take that information and correlate them, then I can understand the activity, the behavior, and the experience. Right? This is just from one piece. What if I'm able to take data from multiple sources, right, and be able to aggregate that? Now I tend to understand the behavior of a population, which essentially could be a pattern, right? And once I get that level of information, I can now customize things based on the contextual information that I just now received, right? Let's take the traffic example. If I find out traffic every single day from 8 to 9, and I understand it over a period of time, I can essentially tell a person, like I was talking to you about coming here, driving from my home to the airport, it can essentially say how much time it might take me to drive at 8:15 a.m. or 8:30 a.m. or 9 a.m. or whatever it might be, right? That's the level of customization that we can offer if we start to use machine data, right? One of the things that we have found with machine data is because, like I talked about, these being in silos, the application today is very much in security and in IT operations. And I want to talk a little more about that as we go through. But the key thing to understand here is that when I have this data, be it from a web server, be it from a router, be it from a network device, whatever it might be, the key thing here is that I can use it across multiple areas. That being offering multiple lenses. Let's take logs, for example, from a web server. The web server generates logs. The IT department, right, can probably look at it and say, I put in a new patch, how is the web server performing, with this change? Kind of helps with change management and configuration management in that area, right? The security person might look at it and say, I want to be able to take these logs and look at what kind of malware might be coming through. How is it doing from a security perspective? If I had a business analytics, right, department, let's say the Department of Motor Vehicles has just put out a new application, they might be able to look at usage trends and then tweak things based on how people are reacting to it. So essentially the same level of data is now applicable, if you will, across multiple areas, right? That is very, very important. And that talks to total cost of ownership and return on investment. Today, if you go back and say, how am I doing it today? From a business analytics perspective, you probably have a solution for it, right? If you want to do security analysis, you probably have a solution for it, right? But if I take the same data and I'm able to correlate them with the appropriate information, which a platform should be able to do from an analytics perspective, right? Based on the questions that you ask, now I have a completely different paradigm, right? Able to take a platform and use it essentially across the local or state agency, regardless of what the challenge might be. That's what that is. Essentially, when you take something, right, you're using it across the board. We've got customers you're using such a platform, the Splunk platform, obviously you probably realized it by now, is something that does that. You can start with IT operations, you can start with security, you can start with even environmental monitoring, right? And based on that information that you get, you share that information with other departments. You're now able to come up with multiple usage scenarios where you're solving challenges without having to invest in multiple products and then have other silos, go through your city or state. Just going to very quickly, let me take a look at let me give you an idea about the security piece. When we talk about security, we're talking about a very limited set, right? Normally, this is what SAMs do. They essentially take information from security devices, authentication information, firewalls, IDS, IPS, next-gen firewall, Palo Alto, whatever it might be. It's getting information, right? It's going to aggregate them. You set some rules for correlation, and then it tells you this is what I found. And if you want to find something else, right, now you have to kind of change rules, add rules, whatever it might be, and then now you're able to find more information. So essentially, you're looking for things. But what do you do when you don't know what to look for? In a lot of cases, when we talk with security folks, that's what we hear, is that we don't know where to start. We know there's something going on, but we don't know where to start, right? So from that perspective, you should be able to essentially ask a question and then take it from there. Walk things, understand patterns from that perspective, from that perspective. But when we talk about the case of machine data, right, we have access to more information now. Let me give you an example. You guys are here today, right, at the conference. Let's say there's activity coming from your desktops back at the office, right? Somebody might say, well, John's working hard. You know, I see some activity going on. But what if from the travel management system or some other application that you have that records that you're traveling, right, that says, no, John's really not in the office. He's traveling somewhere in Wilmington, North Carolina, right? That's something for you to be concerned about, to be alerted about. Another example might be where I've got a USB, I'm copying a bunch of files onto it. In a lot of cases, that may not be necessarily by policy. It might be against policy to take sensitive material. But I could tell you that while I'm going home to work on my my favorite computer, that's where I do all my work on the weekends. I can't take my laptop or my desktop from the office, right from here home, so I'm going to go and do that then. Fair enough, you're being productive. But what if you find out from the HR system or some other system that says, this guy just gave his notice, he's going to be leaving the company or leaving the agency, for that matter, right? That's something that raises red flags, right? That's the kind of contextual information that you're able to now provide, right, with this type of analysis, this type of data aggregation, right, in order to be able to chase these threats down. The other type is always the one that we have traditionally been talking about, and that is these advanced threats, right? APTs, advanced persistent threats that come along, where people want hunters, people want to be able to look at what is going on, and to your point, we want to be predictive. In other words, see what is going on. What really is needed at that time is not data from about 30 days ago or 60 days ago. It is useful because you can do some forensics on it and see what might have happened. But what if you can get that data in real time, right, in order for me able to do this? If we walk this advanced threat scenario, it's something that you've probably seen before. An attacker hacks into a website, right? He takes a PDF file from there, he embeds malware into it, and then essentially sends it to somebody, and who's unsuspecting user says, this is very, very interesting, I'm going to click on it, right? And they essentially get the file dropped, they compromised, phone home, right? You understand the kill chain. Going through the whole process, at the end of it, they're able to exfiltrate the data. Think about what you have to do today. I mean, we'll just pause and say, if this was a scenario, how do you go about solving this problem at your agency today? Can someone volunteer for that information? Is it running between multiple? Yes, sir. Oh, you would say something. I thought you were going to say something. Sorry.
No, it was your.
So a lot of times what we find is that people go to these individual consoles, right? Look at firewall logs, right? They're separate. And then they have to try to figure out something from a threat intelligence source, right? And they might have to look at host activity. So all these things are happening in silos, right? It's a manual process, it's ad hoc, and kind of running between multiple pieces to piece this thing together, right? You'll find out in one of these areas where one of our customers, they've had 4 million attacks per week. That's what they're seeing, right? When you have something like this, you can't staff up enough to run between consoles in order to be able to do it. So what you're looking at from a machine data perspective is essentially getting everything in one place, the aggregation piece that we talked about in the correlation aspect, where now you're able to walk back and see what exactly happened, right? All the logs are in one place, and you're essentially able to analyze, right, the path. You're essentially reverse engineering at this point in time, and you're able to figure out what exactly happened. You may not be able to stop it right then and there, but soon enough to control that damage. That's the key, right? By having all this information, the log information, and all the different pieces from everywhere across your enterprise or across your agency, getting it into one place, right, aggregated and correlated, now you're able to ask the questions to analyze what is going on. Right? So that's the whole idea behind this concept. I want to pause and see if there's any questions at all. Machine data concept is clear? Okay.
Ashok,
Let me just add, my name is Keith McDaniel, I'm the state and local rep for Splunk, supporting you all. As a reference to this particular point, we had a Discovery Day in Raleigh last week. I don't know how many, if any of you were able to attend. But we had UNC Chapel Hill speak as how they use Splunk in their environment. And this is the exact scenario that they use except for phishing attacks. So they have, somebody comes in, they recognize a phishing attack email, they reverse engineer it and respond as a suspected user, and they're able to track back to when and start communicating with the offender, and then be able to take that data and send it to law enforcement. So it's really interesting if you look at, this is a specific case of just a web interaction, but that's a real life case of how one particular use case for protecting yourselves using this type of technology.
Excellent. So I'll give you a couple of examples of, departments, local, cities, states, using, machine data in order to aggregate information, get it on one place, correlate them, and search and look for insights so they can make their decisions. This is the state of Alaska. They were looking for 7 people to staff up on their security team, and they knew with their budgets and things like that, because of the oil, downturn in the oil business, right? They were not going to be able to get the resources. They essentially bought this platform, this Splunk platform that we have, which essentially aggregates these tools. And what they found was that they were able to reduce the amount of time that the analysts spend, right, hunting for things. They had all the data, they were able to pull it all together, and they were able to find things that they did not know before, right? And they were even able to help their fusion centers, right? When they came up and said, hey, here's something that we have, like, can you please take a look at it? And they were able to analyze the data within minutes, is what they told us, in order to be able to get there. And the reason they were able to do it is because they were able to get that end-to-end visibility. They were able to get this data called machine data, which is essentially now the authoritative source, right, of all activities and behaviors, and all in one place, correlated, so they could just ask the questions that they needed to in order to be able to hunt for things that they were looking for. Sometimes they would just go in and look at one piece, if you will, right, and then they could not go any further because they didn't have the data. They had to stop, go to a different console. That essentially, was something that they had tremendous cost and time savings from. Chandler, Arizona Police Department, they were using it for public safety. They started out, looking at it for, if you will, security. And then they found out that the same thing could be used, if you will, to what we will call, looking for data from their records management system and also their call dispatch system. They were able to look at the calls that were coming in, right? Look at the response the policemen were having, what kind of areas and things of that nature. And from that perspective, they were able to do some predictive analytics to see where people needed to go. So that's something that's enhanced their citizen service or the response or their public safety systems from that perspective. City of San Diego, they started out, again, using it for security. These are the folks with about 4 million attacks per week, right? They can't find enough people if they're going to investigate every single piece that is coming along. So they had to do something, right, in order to be able to protect 40,000 endpoints in 24 different networks. And what they found was that they could use a platform that offered end-to-end visibility. They can't, function in siloed departments, and they had to pull all the pieces together, which essentially helped them, enhance their security posture. They were able to find that a lot of the data that they were getting could also be used for city services. Of course, not the same data, but they had to have other contextual data as well. But they're now looking to essentially improve their city services, garbage collection, the streetlight example that I mentioned, and things of that nature. So that's something that they're moving on. Clackamas County. This is something that is very, very interesting, and one of my favorite usage of machine data. There are about 380,000 people in this county. What's the average size of the counties or cities here in North Carolina? 100, 200? So this is about 380,000 people in this county. In my mind, it's a pretty small county, especially because I come from Northern Virginia, which is pretty large, the counties there. They started to use it for monitoring Windows logs. right? And that's all they started because the log application that they had was not working very well. It was slowing down every 30 days. They would do a search, took them 15 minutes. If there was something wrong, that's when they would know about it. They'll have to redo the search and things like that. And what they found by aggregating all this machine data was that, number one, it helped them with the security. You can imagine a county like this, if San Diego and Los Angeles and folks like that are having trouble finding people, right? Clackamas County is probably having a lot more trouble as well. So these people were having some issues. They were able to use the same thing to improve their call center experience. Essentially get machine data based on their call center application and then use that, get some insights out of it in order to be able to improve that aspect. The other thing that they were able to do was, with the sustainability initiatives, they were also looking to make sure that they're not using a lot of resources. They have a sustainability department. What they found was that they were printing a lot. So they essentially looked at all the machine data that's coming from various printers, and they were able to find out that 60% of what they were printing were coupons. And they were able to tie it back to one person. And all she did was just sit there and print coupons all day, right? They started out at security, and they came all the way to, trying to figure out how they're going to save some resources. So they were able to, essentially tell the lady politely that, hey, this is against policy, you can't be doing this kind of stuff. There was another area where they were looking at temperature. They were, looking at temperatures of all their rooms, and essentially, one of the data centers they had, they were looking at, the server room. They had temperature sensors. Some company had come and said, here's a temperature sensor that you could use, and they had set it up, and essentially they fed it back to their application. That company was charging the county back $6,000 or something of that nature per year just to monitor it. So it was their sensors, it was their software. For monitoring that, they were charging them back. So what these guys did was they just went and bought some sensors themselves, right? And using some SNMP calls, they were able to get information back from the sensors, and they brought it back, the machine data, if you will, brought it back into the platform. And when they did that, they were able to essentially save the money that they were paying on that. And for a county of that size, from what we heard, that $6,000 was quite a bit of money, and they could use it somewhere else. So when you look at machine data, for example, it has various applications. People start from one area, regardless of where the problem might be, and then move on, right? Whether it's security, whether it's IT apps, application delivery, or essentially looking to see how city services are being delivered, right? Or ensuring that there is no revenue gaps or leakage, The machine data can offer you, if harnessed properly, if aggregated and correlated and analyzed properly, a whole bunch of, paradigms that you can start looking at, different offerings that you can bring, and start to essentially, manage your county or your city much more efficiently and much more productively. Okay? So that's what I have so far. Any questions? My colleagues are there, and they've been with Splunk for a while and answer the questions.
What's the easiest way to gather all this data and bring it into the platform? Is it you save log files, or does it go look for the log files? Do you have to input them and tell where it's going? I want to understand how it collects the data.
So basically, there's multiple collection mechanisms. You can have forwarders, you can have, listeners, if you will, that are sitting off some tabs, essentially collecting the data and sending it over. And the key thing here is that when we collect the data, we're not essentially normalizing and storing it in the database as such, right? Essentially collecting the data and keeping it there, right? We know what the format looks like, but then we call it schema on read. What that means is that when you ask the question, we pull the necessary data in order to be able to show it to you, if that makes sense. Tony,
Sure,
you want to add something?
let me jump in here. So first of all, this is Keith. He comes with a USB drive. He plugs that into your server, and then he walks it back. No, I'm just teasing. So we have something called the universal forwarder that could sit on any sort of host machine.
All right.
And it's very lightweight. It'll send data into Splunk real time.
Okay.
We could also listen to events too, meaning we could pull through Windows WMI protocol. We could pull data in directly if you don't want the forwarders. We have a capability called stream, so for those network folks out there that have used Wireshark in the past, we could also pick packets off the wire. HTTP, FTP, there's over 80 protocols To Ashok's point, we're really good at indexing that in real time and also applying a schema to it so you can get the nice reports and dashboards and alerts. Which really, our message today is take that machine data, which is, in days past was throwaway garbage, junk, but it actually has really good value to it. That value being, operational efficiencies, security, and then business-facing events, being able to monitor services to your citizens like transportation and transit and lighting and heating, cooling, park safety, you name it. Any of that machine data can use to augment those city services or county services, which ultimately, make you leaner, meaner, more financially efficient, but hopefully, from a citizen-facing perspective, you're delivering better services, which translates into governmental success, right? So we believe there's value in that data, and we try to make the economics work. So if you put $1 in, we try to get your money back, and more so, right? Because it's always a financial argument there as well.
One of the things I just wanted to address and kind of came up with everybody in the beginning is the funding for cybersecurity. Everybody would like to do more, but it's always hard to get the dollars. When I first started with Splunk, one of my first calls was with Mike Dent, who's the CISO for Fairfax County in Virginia. It's 1.6 million residents. They have an IT budget that's larger than 5 states. And so he came in for a demo because the folks that he uses as staff log to run his security was interested in moving to Splunk, but he wanted to see what it was. So they came into our office in Northern Virginia, and we had a gentleman similar to Charlie stand up front and do the demo. And when he saw the dashboards that we have from an executive dashboard perspective, he sat through about half of the demo and then walked out and said, I want that. And he said, I know that the SIMs are SIMs, and I'm sure yours is great. I know it's going to do what I need to protect me. But what I'm not able to do right now is articulate to our director and the board how much of risk we are at in a way that they can understand it so that I can get the funding that I need in order to do the security stuff that we have. So we just got them installed. They bought back in October. We just got them fully implemented right before the lines of business conversation for FY17, FY17. And he, for the first time, got 5 headcount and $460,000 more in his budget, in addition to the large budget that he has for staff log in order to have people manage and monitor his Splunk and continue to do the resources. So having the right dashboards and tools to show the threat that you have and be able to, it's kind of scary stuff if you start looking at millions of hits on your network, and it's in a graphic that an executive that doesn't understand cybersecurity can understand. It's pretty compelling. So, sure. I'll just turn it back over to you.
Go.
Done?
People have any questions?
You talked about, once you get the actual events going into the system, that at that point, it's just about asking the appropriate question to get the answers that you're looking for. How difficult is it to configure the system so that you're asking the appropriate questions and you're getting relevant data out of it, as opposed to just a bunch of guesses, I guess, or a bunch of unuseful data?
Yeah. Charlie might be best to answer the question.
Great question, first of all. So Splunk has actually authored applications that should answer a number of those in the different buckets that we sell into. So for example, we have an enterprise security application. And general security asks are, what does my intrusion look like? What does my landscape of malware look like? What does my vulnerability look like across my network? So this enterprise security app that sits atop Splunk will answer those questions for you. Okay. It'll also create something called a risk modifier, meaning that if any of those security breaches exist on a host or a PC or a network device, it'll score that in terms of its risk number, if you will. So a higher risk score means that those hosts are likely compromised. So it's Splunk actively trying to tell you something rather than you, the user, trying to Google search it and figure it out. that helps eliminate false positives. We also do that in the IT operations side of the fence, where we look at infrastructure that's struggling in terms of its health score. So if you look at a 3-tier application, database, app server, web server, storage on the back end, we'll tie all of that log data together for you. We'll apply our algorithms and mechanisms to give it like a 0 from 100 score, 100 being healthy, 0 being dead, and over a 24-hour period, we'll show you a trend line of where that app is going so you could take corrective action. So we started out as a log search and hunt mechanism, but over time we've provided apps to sort of answer those questions. Now, you could also, besides the apps that we author, we have a language, a search language that you could apply, which is essentially a grep-like language, to ask those questions should you need to go beyond what we provide out of the box.
I got you.
But it's very much sort of a command pipe, if you're an old procedural programmer like myself, very comfortable language. You can also work with the interface and point and click mechanism too. Beyond that, there was a question about predictive stuff, right? So we have a fantastic machine learning library that will do all your big boys like regression, clustering, anomaly detection, support vector machine. Those are the old SAS algorithms that you may know from SPSS days, but that's built into the core Splunk. We can do time series forecasting, so that works great in trying to predict system outage. Also maybe do clustering in terms of crime statistics within wards or districts within a municipality. So take away from that, Splunk is sort of all-in-one tool, whereas some of the older architecture, you got to buy a database and middleware, maybe a BI tool. We provide that out of the box in a single solution. So, in a pricing model that I think is very fair. So it's a new architecture that's real time, that works in the big data space. So hopefully, I'm probably philosophizing now, so I'll be quiet. But hopefully that answers your question. We can take it offline.
No, yeah.
Chat more.
Yeah, that's great, and I think the only thing to emphasize there too is we have Splunk base. If you think about it, it's kind of like the App Store on the Apple side of things, and we have about 1,200 apps on there. We only charge for 4 of them that we build, and it's the Enterprise Security app, ITSI, so IT Service Intelligence, Exchange, and VMware. All the other 1,200 apps, in addition to that, are for managing your NetApp environment, managing your AD environment, managing your firewalls, whether they're FireEye or, Palo Alto, your Cisco infrastructure. And those apps get you about 80 to 90% there and have the questions pertinent to people who've run those infrastructures before, and yet you can augment them similar to what Charlie mentioned.
So these community-based apps, or is it just Splunk engineered apps? Or?
Yeah, so the answer to that is yes, right? So we have apps where our engineers have written and gone through the process to publish, not unlike the Apple Store qualification. We have third-party partners that have written their own app and they maintain them. And then we've just had people that got tired of waiting on something and went out and wrote it. I'll give you an example. So Silence, I don't know if you guys have heard of them from an endpoint perspective. They do not have what we call a TA, which is one of the tools that we use to add on. It's kind of the technical name for these apps that you use to get where you need to go. And we had a PS engineer on site with Fairfax, and that was their endpoint. And they had stopped really monitoring and kind of care and feeding of their app. And our PS guy, while he was there, wrote the new one and published it. So those kinds of things happen. And to that point, we have a huge user base. And the language is the language is the language. So 76% of our support cases get answered by our community before they ever reach our support. It's pretty incredible number if you think about that.
So the licensing model, is it by number of data sets, data types, and number of endpoints feeding Splunk?
Great question. So the way we index, and this is really important where it goes back to asking different questions of the same data, we charge you by the amount of data you index in a 24-hour period. So we come in and look at your sizing, we figure out how much you index on a daily basis, we give you a little bit of headroom for event management and all that kind of stuff, and then that's the license. And we have traditional licensing models, perpetual or term license, where where you pay every year. It's a little less expensive than a perpetual license, but you own it and just pay maintenance and support. And the beauty of that is that once you get the data indexed in the tool, we don't charge you based on how many people put a lens on that data and look at it differently. Security data is relevant to everyone, but then that data is also interesting to the network engineer, it's interesting to the storage engineer, it's interesting to the application development folks, but those are all different bills in a traditional environment. With us, once you get the data in a single environment and it's indexed, you know, your data there, then it's just, you're only limited to your own ingenuity as to what kind of value you get out of the data. We do have a cloud product too, by the way, so if you don't have infrastructure that you can stand up right away to support your environment, and it's just a flat 33% uplift on our term license, and it comes as a managed service. So we provide not only the hardware, but the engineering on that side to make sure that that instance stays up and running. And that's what Fairfax went with. They stood up, they have 600 gigs a day going into, and think about that, 600 gigs is just text data. So think about the number of logs. So when Ashok showed that first screen with all the log data there and doing the correlation, think about doing that on enough text data that would be on an 8.5 by 11 sheet of paper that if you put them end to end would wrap around the moon and back. And being able to find that data instantaneously in that amount of data. That's about 400 gigs. So it's pretty powerful stuff.
Well, I stopped by your booth yesterday, and I got a kind of a nice little demonstration, and I don't want to discount cybersecurity, and that's the theme of our conference, but I have a different area of focus. We are getting a lot of attention, and we already have, and you mentioned the silos with the different departments doing things. We've had IoT type initiatives going on for a while, and you know, now IoT has been rebranded to smart cities and things like that. So as all this data is being collected and these sensors and things are going out there, I have to be able to consume this data on somebody's behalf and do something with it. And so, you know, my focus is, okay, how can I do that and turn it into something meaningful for my business units? For example, if there's a sensor on a garbage truck that can measure every time because we do have some commercial customers that the city picks up for. But even beyond that, if you just considered residential communities or and condo complexes, those are the ones kind of where we charge because it's sort of an entity, or apartment complexes, but the city's still picking some of those up. How does he go about figuring out how much tonnage he picked up for each site? I mean, that's a huge problem for him, because the only way he can truly do it is to scale each time he picks something up. Well, we don't want him driving and finding a set of scales every time. So, you know, a lot of this is estimation and guesstimation, and we don't know if people are being charged the proper amounts or not. But, you know, if there's a sensor that, you know, he can mash or weigh ahead of time and then collect that on the whole journey, and then, you know, I get it at the end of the day, guess what? I can do a lot better billing with that. And then there's the sanitary sewer overflows and, you know, just all these other areas where people are wanting to put these devices, and it sounds so cool. Oh, yeah, let's have that. But then they're going to look back to me to make sense of their data.
Yeah, you make a perfect point. So, and I want to give an example that I think will highlight that, but on a higher level. So we talked about our split in business. So globally, we're about 60% IT operations, 40% cybersecurity, if you just pie charted our business. If you go to our public sector business, it's the opposite of that, right? We're about 40% IT operations and 60% cybersecurity, although that's coming together more and more every quarter. Right now, our IoT business is a rounding error in that, right? I would say it's 2 to 3% of our business overall, and I would include industrial sensors in that as we go. And it's my vision that within 24 to 36 months, IoT will be the biggest chunk of our business. Because I think the problem that you're talking about, everybody's realizing these sensors can go everywhere, but nobody's realized the value and the power of that data when it's aggregated. They see the power of the data for its specific use case, but once you can aggregate all that data and do correlations across it, it's just like different silos, right? Mm-hmm. So now you've got a much more relevant question. area where you can go in and really make an impact to the business. So an example of what you're talking about, so we had, our CTO talked about this with Arlington County. Arizona State University had a fleet of like 60 cars that they were paying for. And so they took these, we have these really cool like cell phone adapters. It's not unlike probably what Progressive would put in to see how you're driving to see if they lower your rate. But it has a cell phone transmitter in it, and it collects data and sends it directly into Splunk Cloud. So they bought 60 of those and put them out into their fleet and tracked it. And they just thought that that was an inefficient part of their business, so they wanted to manage it. And they realized that only 12 of the cars ever moved. And they were paying a ton of money to manage and maintenance and support of all those. So they were able to reposition, get rid of almost 2/3 of their fleet and reposition those cars so that they were the most effectively used, and then monitor to make sure they were being used appropriately from that point on. But if you think about having that kind of sensor then that's in a garbage truck that then can go straight to Splunk Cloud, so they don't have to go to like a Wi-Fi access point to share the data, so it's updated by route. There's all kinds of applications for that in a state and local government environment. I think about, water, sewer companies, checking the pressure in a water pipe to see if they can be predictive about what's about to burst. There's a lot of different elements. Parking meters everywhere, and I think that's a pretty straightforward opportunity for tracking where citizens are and where parking space is. And
We like to put sensors in the streets or along the curb or something like that, so that we know if there's a vehicle parked there.
Sure.
Because if I know where there's available parking, I can have an app that somebody can look, hey, I'm downtown, I need a parking space.
Yeah.
Hey, there's right now there's 4 spaces over one street over from where you are. Here you are, just.
City of Virginia Beach is doing that now.
And
So
I mean, we've collected geographically, we've geocoded all of the public parking spaces, but we don't have, so I can tell you where there's parking, but today I cannot tell you if that space is empty, but it's very easy to do that. We're hoping to maybe do some of that with some of our grant monies and things around smart cities.
And this will be I'm sorry, just one last thing, and I'll wrap up because I know we got to go, and I'll let Ashok finish up. The important part of that is you need a platform that can scale, because the amount of data is phenomenal, right? So if you think about, we have Cap 1 right now is ingesting hundreds of terabytes of our data a day into a Splunk Cloud tool to be able to make available. Ashok was telling me last night our biggest customer in public sector is doing 2 petabytes a day in the tool. So if you think about having something, you can buy a 5 gig license and solve your CGIS compliance issue that can scale then out to something that can support an IoT infrastructure across an entire municipality. That's kind of where we're going, and I think that's the exciting part of where we are, because the sky's the limit as to what we can do with the information we get.
Keith makes a very interesting point, because when it comes to scale, a lot of times people talk about, throwing pizza boxes or, racks of equipment and things of that nature, right? Just to do the processing piece. Talk about the enterprise side and also the cloud side too. Our smallest customer in the public sector is 500 megabytes. So we can start very small and go to 140 terabytes. The largest commercial customer we have is that 2 petabyte customer. We can process that level of information. I think the key thing to understand is that as we move along, yes, bandwidth's going to start improving. So there's going to be all sorts of technologies that's going to come in order to be able to do this. But at the end of the day, where are you processing it? What are you trying to do with? Will always enter the equation, right? And so scale, from what Keith was talking about, is going to be very, very important.
Well, we want to be sensitive to your time, so no other questions. We'll give you back the remainder of your day.
Yeah, thank you very much.